This video has been made possible by Stepcraft. I love all types of manufacturing, especially CNC machining. Years ago, I built a custom CNC machine with a friend, which started out as a basic open build, but over time I modified it until it became a completely custom build. It served me well, but over the years it's developed issues, and because of that, I just haven't been machining as much as I'd like to be. To get me back into CNC machining, Stepcraft have sent over their M1000 Black Edition for me to use in my upcoming projects. One thing I want to do is round off the charging stand project by machining a Walnut version of it, and also machining some Walnut for a flat desktop charging pad that I've also been designing. In my case, I've had this delivered as the full self-assembly kit, although you can have this shipped as a pre-built machine. But either way, this is going to be a huge step up from what I was working with before. This version of the machine has got high wind ball screws and a semi-closed loop system with step monitoring on each axis. All of the electrical components are secured in an enclosure on the rear of the machine, keeping everything nice and neat. Once they're all in, I can build up each section of the machine following the instructions. Once all of the separate assemblies are complete, the machine does start to come together pretty quick. Starting with the sides that make up the Y-axis, I can set them in place and bolt them together. Then I can install the gantry side plates, then the extrusion that makes up the complete gantry. Stepcraft designed all their aluminium extrusion in a way to make the machine as rigid as possible compared to just standard aluminium extrusion. Next, I can secure the Z-axis carriage to the gantry, and then I can mount the spindle into the holder. Now all the wiring's routed and everything's together, I can make a start on installing the bed. This comes with an MDF T-slot bed as standard, but there is an aluminium version which you can spec. There's also an additional vacuum bed that can be installed, which I am looking forward to trying. Having the T-slots will be useful for clamping and securing jigs down, but the most useful addition for me is the auto tool changer. This will make operations with multiple tool changes so much more straightforward, and maintain the accuracy of the tool height between tool changes. I can load all of my most frequently used tools into the holders, and during the initial setup, it'll measure the length of each tool and save those values as the offsets. Now setup is complete, I can move on to some machining. To machine the Walnut front section, I've done all my tool paths in Fusion 360, which is mostly adaptive clearing operations, along with a geodesic operation with a 0.05mm step over for a really clean finish. For now, I'm going to treat this first operation as a test. Ideally, I do these in batches from a longer piece of walnut rather than just a small piece of stock. I'm going to secure this down to a piece of MDF spoil board with the tape and glue method. The machine also has a workpiece offset sensor for accurately finding the workpiece zero. Now I've set my zeros, I can start machining. I'm starting with the adaptive toolpath with a 6mm end mill. This is going to clear the majority of the stock, leaving 0.2mm stock for me to machine with the finishing operations. 3D adaptive operations are much more efficient than pockets, as I can set the maximum depth of cut and tool engagement. Then it'll calculate what it needs in order to clear all the material in one operation. Now that's finished, the G-code will tell the CNC to switch tools. It'll drop off the 6mm end mill and pick up the tapered ball end for the finishing pass. Because this is the same CAD model as the Forged Carbon Master I used for making the Forged Carbon mould, all the walls are tapered. I may change this to simplify machining, although the tapered walls kind of adds to the design and the way it looks. For the best surface finish, I chose a 0.05mm step over to ensure there's no cusps that need sanding out after. Although this will add a lot of time to the operation, and I'm talking hours. The way I've justified this to a point is I can go with a bigger step over and spend extra time sanding the surfaces flat after, but I run the risk of softening all the edges the more I have to sand, as well as adding more manual labour to the operation. I will have to sand the surfaces regardless, but with such a small step over, it's really going to be minimal sanding. I'll likely have to find a middle ground with this though, because this just isn't going to be practical for any sort of production with the machine in time where it's currently at. Now that's finished, I can machine the holes for the bolts and for the pockets for the component that holds the front charging holder to the body. Once they're done, I can run a quick deburring operation just to clean up those edges. Then to finish it off, I can run a final contour operation to cut the component away from the stock. Before moving on to machining the back, I need to glue in the insert I've made that goes into that slot. I'm using some methacrylate adhesive, which does a great job at bonding different surfaces together. I've designed some small channels underneath that I can apply the glue into, just so there's a bit of volume there, rather than ending up with a really thin film of glue. So the next stage is to machine the back. Now, because I've machined the front already, I've not got a flat surface underneath, so I can't just glue this down like I did before. I also can't use clamps on the top or the sides because they'll get in the way of the machining. So what I've done is designed a jig where I can secure the workpiece in from underneath. So this locates onto the jig, and there's some machine screws that go in the back into those brass inserts that I just installed. This means that there's nothing obstructing the machining from the top, and I can also just drop this in as a single assembly because the jig lines up with the T-slots on the bed. So to set this up, I'm securing down a piece of laser cut acrylic as a fixed reference point along the X-axis. The Y-axis is aligned because the slots themselves are in fixed positions. I can then zero the CNC to the marked point on the jig. I'm zeroing to this because there's no defined point on the back of the walnut where I can accurately zero to. The drawback with this is now I've aligned it all, I have to remove it to secure the walnut to the jig. This is why I put the acrylic piece there as a stop, so when I reinstall the jig, it should go exactly back where I aligned it to originally. A better way of doing this would be to have a 0-point vise and have the piece that attached to the front of the component clamped to it, but for this initial run, this should work just fine. Now that's secured, I can continue machining the back. I'll start with an adaptive operation to clear as much stock as possible, leaving 0.2 mil for the next operation. The flat surface on the back isn't parallel to the surface on the front where I installed those brass inserts. So it's not as simple as just facing off the back with the end mill. I've used the same finishing operation here that I used on the front to take away all those steps and islands. With my old machine, I wasn't able to run this very fast without the motor stalling, but I've noticed as it's been machining, this can handle pretty aggressive clearing at decent speeds, which my old machine just wouldn't have been able to cope with. If you want a full rundown of specs and all different configurations of the M series machines, I've left a link in the description where you can view all the details. Once it's finished, I can remove the jig, then remove the component. I've really enjoyed watching this come together. It's always nice to see something that you've made in one form and then make it out of a completely different material. It just gives the same silhouette this completely different feel. To finish this off, I've given it a light sand all over, and I'm just going to apply a couple of coats of Osmo. So while I wait for that to cure, and before I'm able to assemble everything, I just want to run through a design change I've done with the charger holder. So originally, I was casting a flexible polyurethane piece that would wrap around the front of it, and its main job was just to hide the charger for a clean look. Functionally, this worked really well, but the problem I was having was between each cast, I was getting inconsistent thicknesses. Now, the thickness of that front piece is really important for those magnets in the charger to work properly. So any thicker, the foam wouldn't really stay on. Any thinner, the part itself wouldn't really have enough structure. So I couldn't really solve that. And when you combine that with really long cure times for each cast, the molds aren't really that scalable because of the size of them. Overall, it's just not a method that's practical to move forward with. So I wasn't sure what to do, so I kind of just left that. And while I was designing the desktop charging pad, I introduced another element into that, which was to trim the middle piece in Alcantara for another automotive tie-in, because generally you find that in higher end vehicles. That gave me the idea to revisit this and follow that same approach. So this is the printed piece that slots over the front, and it's got a really thin, it's actually just one printed layer over the front, so the Alcantara can float over the top. I did try it without that, but what you find is the Alcantara sags, and you can also see the glue on the back, on the inside, which just isn't very presentable. I've laser cut my piece of Alcantara and already sprayed contact adhesive on the back. For the front, I can't really spray that directly onto it, so spraying this directly into a lid will allow me to just paste it on. The adhesive that I'd normally brush on when doing this application with Alcantara is slightly too thick, so doing it this way just allows me to paste a really thin wet layer on. And now once that's touch dry, I can apply the Alcantara. You might have already noticed, but I've left a channel around the edge, so I've got somewhere to tuck the edge of the Alcantara into to make sure it's a nice clean finish. Also, just want to point out that this is genuine Alcantara. So Alcantara is a brand name, not the name of the material. Alcantara is what you'd find, it's what manufacturers tend to use. So Audi, this is what you'd find. I think you'd actually find that colour, which is charcoal 9002, in R8s when you spec an Alcantara headlining. It is actually that same one. There are other cheap alternatives, which I'll quickly show you. So you've got this stuff, which is a faux suede. It's really thin, normally comes with a backing to keep it all together. Any cut, you'll get a frayed edge, and this stuff will 100% fade in the sun, so it's not UV stable. This is about £15 a metre. Genuine Alcantara, you just feeling it, it's thicker. You cut it, even with a blade. I know I've laser cut that, but it doesn't fray, and it is UV stable, which comes in about £100 a metre. So that's the real stuff. I always use that on my automotive builds as well. I never use that stuff. Now the walnut piece is ready, I can secure it to the main body of the charging stand. Once that's on, I can feed the cable through the charger and secure that into place as well. Then it's just a case of clipping that front piece over the charger holder. Now I've seen this all together, I much prefer the way the Alcantara looks over the cast flexible polyurethane piece. So now I can shift my attention to the charging pad. This is a product that lives in the same collection as the charging stand, but it's just a flat and simplified version. I designed this mainly for my AirPods, but I can also use this to charge my phone, as it also uses the MagSafe charger. This is a clamshell design where the machine screws go through the bottom and screw into the very top piece, aligning and clamping everything together. Thinking a bit further ahead into the workflow, I've designed a jig that I'll machine that can hold the walnut pieces when they're drying after they've been coated. To machine all of this, I want to try out using the vacuum bed. Although the M1000 came with a full-size vacuum bed, I'd like to have a setup where I have the option to use both systems without having to keep swapping them out. So I've reverse engineered the design so I can have a smaller version at the front of the machine. To start with, I'm using a 3mm end mill to rough out all the channels. I'm leaving 0.5mm axial stock, as I'll be going in with a 3mm ball end as the finishing pass to create the fillet at the base of each of the squares. I'm also machining the holes so I can secure the bed down to the machine, and holes for dowels so I can align the stock material for repeatable operations. Then I can switch over to the 3mm ball end for the finishing pass. Unfortunately, during this operation, nearly all of the squares with the dowel holes sheared off. I'm assuming there just wasn't enough surface area with the hole in the middle to keep them in place. I let the operation run its course, but as it ended, I also realised I'd mistakenly used a different 3mm end mill rather than the ball end. The fillet not being there at the bottom of the squares might cause an issue with the sealing of the gasket, but I decided to just see it through rather than starting all over. So at this point, I still have the issue that I'm missing some of the squares. So I came up with a plan. I decided to machine pockets where all of those squares were. I then 3D printed the squares that were supposed to be there with the hole in the middle, so I can glue those into the pockets I've just machined, effectively replacing them. For some accuracy with this, I designed these with 0.2mm extra material in all directions, so I can run an operation to machine those down. It's really important for these that they're the exact dimensions of all the other squares that are on the bed, especially the height, because if they sit too high, the stock material isn't going to sit flat. From there, I can swap over to the 6mm end mill to machine the hole for the vacuum port. Then run a final contour to cut the vacuum bed out. I can then run one more deburring operation to really clean all those edges up. Final operation is to cut the slot or undercut inside the vacuum opening. This is for an O-ring to sit inside so the vacuum hose makes an airtight seal. Now all that's complete, I can remove the new vacuum bed and get on with installing it. To do this, I need to remove a portion of the T-slot bed and run the vacuum hose through the tabletop. I can then install the elbow into the bed and drop the bed into position. Then all that's left to do is bolt the bed to the CNC and it's ready to use. To set things up for machining the jigs, I can install the gasket and place some spoil boards in the middle. I'll be machining a few of these, so I'm going to use the dowels so I can set the ply against them and have my 0 set for repeatable operation. Then I can turn the vacuum pump on, pulling the ply down to the bed and remove all the dowels and then start machining. Machining these is pretty quick. I can clear out the pockets for the printed components using a 3mm end mill. Then change over to a 6mm end mill to do all the outer contour. The 6mm end mill is a compression bit, so it's done a good job of favouring the top and the bottom edge of the ply, but the 3mm end mill I've used for the pockets is an upcut. So to sort that out, I can run a deburring operation to clean those edges up. There's really minimal amount of cleanup to do after deburring those edges, but now they're complete, I can get it removed from the bed. So to assemble these, I've designed these 3D printed components that I can glue into place. These are basically standoff pins where I can slot the walnut piece over, they align with the screw holes, and it'll keep these elevated so it's not sitting directly on the work surface. I've also designed some feet which slot over each corner and also allow these jigs to be stackable. Next, I can set up the walnut stock for the charging pad. The toolpaths for these are real simple. I'm machining an initial pocket above each one. The depth I've gone to is the very top surface of the walls that make up the tray shape. I can then run my adaptive clearing pass to take out the bulk of the material inside the tray, leaving 0.2mm for the finishing pass. I can then switch to my 3mm end mill to machine the holes for the machine screws, as well as the opening for the charger cable to pass through. I can then switch back to the 6mm end mill to do my finishing pass, with a small step over running along the grain for the cleanest finish. Then finally, I can do the final contour to cut them all out. Unfortunately, as I was cutting the second one out, the stock moved. Now, I can't blame the machine here. There's a number of factors that could have caused this. First, this could be my version of the vacuum bed is out of spec, could be incorrect routing of the gasket underneath, loss of suction in my hoover, or even the fact that I entered the stock from the outside. What I'm saying is, this is more likely to be user error. As I don't want to risk this happening again, and to save time figuring this all out, I'll just go ahead and use the tape and glue method and try it again. Obviously, all the tool paths are the same as before, as I'm just running the exact same operation again. This time, I was able to successfully cut out all of those without the stock moving. Now they're done, I can remove these from the bed and start on the prep work. I want to test using a 2K lacquer on these rather than the Osmo. This is a lacquer I picked up locally, which ideally should be sprayed on. I have found if I'm really careful with smoothing out the excess, I can get a clean, flat finish. These have all turned out fine, but in the future, for an easier life, I'll likely set the gun up and spray these in batches if I do decide to use this moving forward. I can leave those to cure, and once they have, I can do a test assembly with the 3D printed prototype components. There's an insert that's placed into the walnut, then the charger is clipped into the holder, and that can be inserted into the assembly. Then the base can go on, along with the top piece that's trimmed in Alcantara, and from there, everything can be screwed together. So at this point, I think we can call the charging stand finished. I'm not going to do any more videos on that. I know it's gone on for quite a long time, which I never intended it to sort of drag out, but I think everything that I've documented has been worth showing, all the processes and workflows and everything. But for this one, I just wanted to make sure I did that walnut version, because that was a version from the start I always imagined. So just wanted to make sure that was done. Glad the Alcantara is on the front. I really do like that over the flexible polyurethane. But yeah, done. Next video will be on the charging pad and going through the design, prototyping, and the final version of it, because this is still just a prototype. Other than the walnut pieces, they're obviously all final. And then I'll probably just do one video on that, to be honest. Just go through the entire process and then move on to some other things. But at this point, it is really nice seeing this collection start to come together.